Okay, so we're dividing polynomials again, but this is a shorthand method called synthetic division. It's very, very important that you learn this because it can save you so much time as opposed to long division. And we'll use it later on when we're finding real roots of polynomial equations. In your daily review, you have one of each type of problem that we've done so far. The first one's addition, the next one's subtraction. After that, we have a multiplication problem and then a division problem. Be sure to name each polynomial as well. And remember, when you're naming polynomials, they have two names, which is based on the degree. So linear, cubic, quartic, quadratic, quintic, or constant, and then the number of terms. So monomial, binomial, trinomial, polynomial. And then we'll get into synthetic division. So it's a shorthand method of dividing a polynomial by a linear binomial using only coefficients. For synthetic division to work, the polynomial must be written in standard form. Using 0 as a coefficient for any missing term. So I talked about this in long division as well. If you do not have zeros, you will not have the correct coefficients of your quotient. And then also our third classification, the divisor must be in the form x minus a. So we can't have an x squared minus 3. This just has to be a plain old x. You can't have a 3x or 2x. So it's a little bit restricted in terms of what you can use or what you can actually do synthetic division on. But as long as your polynomials meet these three classifications, then you can use synthetic division, and again, should save you a lot of time. It's a little bit easier to understand, I would say, than long division as well. Okay, so here's the first example. This looks familiar. It's like something that we did in the regular long division notes. 2x squared plus 7x plus 9 divided by x plus 2. But in this case, we're going to be using synthetic division. So step 1 says write the coefficients of the dividend, 2, 7, and 9. So you can see here's the coefficients of our dividend. 2, 7, and 9. So we write them 2, 7, and 9. And again, if you need placeholder zeros, you need to write any placeholder zeros that are not there. In the upper left corner, write the value of a for the divisor. So it's always, you can see this is x minus a. So it is always the opposite sign. So in this case, we have a positive 2. And then when we write the number inside the box, it's a negative 2. So again, always the opposite sign. A tiny, tiny little thing, but it'll give you an entirely wrong answer if you don't make that the opposite sign of your divisor. And then we're going to start by bringing the first number down. So the number from our dividend, the very first number you always bring down. And then this is going to be multiplying and adding. So you multiply this number by negative 2, which then goes underneath our next term. So then we have negative 4, and then we add together. So 7 plus negative 4 is going to give us 3. And again, it's going to be a repeated process then. So then we take 3 and multiply by negative 2, which gives us negative 6, and then we add them together, and then 9 plus negative 6 is going to give us 3. The last number that you get, so you can see this is written in a little box over here, because this is going to be our remainder. And then the final step then, so those numbers don't really mean anything until you rewrite it as your polynomial. So whatever degree we started with, in this case we started with a squared, you have to go 1 degree less. So from x squared we would drop down to x to the first power, or just simply x. and then everything just kind of descends from there. So here's our linear term, here's our constant term, and then we can write our remainder as 3 over our divisor, which was x plus 2. So I'm going to give you 2 examples, and then I'll give you 2 examples to do for the notes, and then on Thursday you guys will have practice to do with this. Okay, so here's 1A. First thing we want to do is take a look at our dividend and see, is it in standard form? Do we need any placeholder zeros? So our highest exponent is 2, and then we have a first, and then we have a constant term. So we don't need any placeholder zeros in this case. So we have 3, 9, and -2. And then we have to write the opposite of our divisor. So we have x minus 1/3, which means we're going to write a positive 1/3 inside of the box. And then you leave a space so we can write our numbers kind of underneath there. And then we start our synthetic division process. So first thing we have to do is bring down the first term, which is a 3. And then 3 times 1/3 is just 1. And then 9 plus 1 is 10. And then 10 times 1/3 would be 10/3. And we're going to have to change -2 into a fraction in order to be able to add those together. So -2 plus 10/3. We need a common denominator of 3. So we'd have to multiply -2 by 3 over 3, which would give us -6/3. So then we can add our numerators and keep our denominator, and we get 4/3. You shouldn't get a lot of fractions with your examples that you're going to get for this. So again, that doesn't really tell us anything. We need to actually write what our quotient would be. So we had x to the second to start, which means this is going to start with x. So we have 3x, and then we just have 10. And then we would have our remainder, which would be 4/3 over x minus 1/3. But again, you're not going to have a whole lot of fractions to work with, even though this example had one. And there is your quotient. So you can see it's a lot simpler, and it saves you a ton of time, especially if we had big polynomials that we had to divide. All right, and then the last but not least for the examples that I'm going to give you, 3x to the fourth minus x to the third plus 5x minus 1. So if we take a look at this, we have a highest degree of 4 and then a 3. We don't have an x squared term, so you have to have a 0 placeholder when you set this up. You need that, otherwise your quotient will not be correct. And then we do have an x term, and then we have our constant term. So we only need one placeholder 0 in this case. Sometimes you may need more than one, depending on what your dividend is. So writing our coefficients, our x to the fourth term is 3, our x to the third term is -1, our x squared term is 0, our x term is 5, and then our constant term is -1. And then remember, when we are writing the number that goes inside of our box that we multiply each time, it's the opposite of +2. So that's going to be -2. And then we need our line to keep everything organized and in place and where it belongs. So with our synthetic division process, bring down the 3. 3 times -2 is -6. Add those together, we get -7. -7 times -2 is +14. 14 plus 0, 14. 14 times -2 is -28. 5 plus -28 would be -23. And then -23 times -2 is going to be +46. And then 46 minus 1 gives us 45. So in this case, our highest exponent was 4. So we have to drop down 1 degree from that, which means we're going to start with an exponent of 3. So 3x to the third minus 7x squared plus 14x minus 23. Works out nicely. Cubic, quadratic, linear, constant. And then our remainder, 45 over our divisor, which would be x plus 2. And there is your quotient for this division problem. Saves you a lot of time, a lot of energy, and a lot of space as opposed to long division. So make sure you complete both of these practice questions. You shouldn't need placeholder zeros. And if you ever end up with a remainder of 0, then technically you don't need to write it as plus 0 over whatever your answer is going to be. As always, let me know if you have any questions.